Hello there. In this video, we're going to be talking about Thevenin's equivalence and Norton's equivalence. When using Thevenin's equivalence, we want to simplify a circuit of resistors and or independent sources and replace it by its Thevenin's equivalence, where you have a voltage source, your V Thevenins, in series with your resistor, your R Thevenins, your equivalence resistance of this whole circuit. Usually you would find your circuit, complex circuit, attached to some load, and you want to replace this complex circuit by a simpler circuit that looks like this. What you do is you want to cut the circuit at 2 points, points A and points B, remove your load from the circuit you want to simplify, and you want to find the V open circuit is your voltage across here, points A and points B, your equivalence. You'll find the voltage when we call V open circuit because it's open, right? And usually how we do that is we put you think about a resistance here, an infinitely high resistance, which would open this circuit, and you want to find that voltage, which would be your V Thevenins and your V open circuit. And then you find I short circuit, which you would short this point from A and B, having a resistance of infinitely small or zero resistance right here. And using Ohm's law, V over R equals V over I equals R. You have V open circuit, where you find the voltage between A and B, and divided by I short circuit, where you short this, you would get your R Thevenins. Your R Thevenins is here, and you would put your V Thevenins here. Now notice that V Thevenins is equivalent to V open circuit, and I short circuit, well, that's I short circuit. And when you divide it, you'll get your R Thevenins. The Thevenin's equivalence and Norton's equivalence can be easily transformed back and forth. These are equivalent circuits. You see this? In Norton's equivalence, you have V Thevenins over R Thevenins would be your I short circuit. You have a current source parallel with your Thevenin's resistance. And in Thevenin's equivalence, you have a voltage source in series with the resistance. Okay? Now, for this problem, we want to find Thevenin's equivalence with respect to A and B by finding the open circuit voltage, V open circuit, and the short circuit current, I short circuit. And then for B, we want to solve V Thevenins. Oh, you want to find for R, you want to solve the Thevenin resistance, the R Thevenins, by removing the independent sources. And we'll talk about it later, but there's a simpler way. So let's start with A. Start with A. We'll find V open circuit, the open circuit voltage, and I short circuit, the short circuit current. Okay. Okay. Let's use node voltage analysis for this circuit. We'll declare our nodes. In our ground ground reference right here. All right. Node A, node B. Wait, hold up. Let me do this. Redo this. Node A. There's node A. To be consistent with A, node B, and node C. We can see that node C is a 9-volt rise with respect to ground. Okay. See node B. Let's write node voltage. Let's do node voltage analysis for the currents going out of node B. Currents going in. The currents going out of node B is VB minus BC. This voltage, this current over 5 plus this current going on, VB over 25 plus this current going out, 1.8 amps. It's equal to how many currents going in? 0, using Kirchhoff's current law. All the currents going in is equal to the currents out. We see that VC is 9 volts. 9 volts. Okay. Now let's write our equation for node A. Node A. We have what current? There's one current going out here, one current going in, and one current going out. Arbitrarily, we define our currents as we please, but I like to use a method where we define all our currents going out unless we have a current source going in. So VA over C, VA minus VC over this resistance is 20 ohms. Some more room. The resistance will be this current plus the current going out, VA over how much? That's 70 because we're doing respect to ground. 70 ohms is equal to my plus equal to 1.8 amps. Okay. We know that VC is 9 volts, so we can plug 9 volts into VC and solve for VA. Turns out that VA is 35 volts. 35 volts. So that VA is 35 volts. Okay. So the voltage with respect to ground, from ground up, is 75 volts. But we want this voltage right here, the one across 60 ohm resistor. So, using voltage divider rule, we say that Thevenin's, which is our voltage across our 60 ohm resistor, is equal to the resistance we want, 60 ohms, divided by the equivalence resistance. We have this 10 ohms in series with 60, so it's 60 plus 10 is 70 ohms, and then you multiply it by the voltage being divided up. What's the voltage being divided up? That's our VA, 35 volts. And that Thevenin's is 30 volts. But this 30 volts, according to our equation, that Thevenin's is equal to V open circuit. So this is our V open circuit. V open circuit. Okay. Now we need to find. Now we found V Thevenin's right here. We need to find R Thevenin's. To find R Thevenin's, we need to find I short circuit. And to short, we must short A and B by replacing it by a wire. Okay. We'll short that. Okay, this is I short circuit. We short A and B to find I short circuit. I short circuit. Okay, notice that when we short this resistance has the same voltage as this wire. Because they're in parallel, when you have resistance in parallel with a short wire, such as this, you can cross this out because it will have no current, because V is relationship of ohms law, V equals IR. The voltage here is the same voltage as A and B, across A and B, which is 0. The voltage across a wire is 0. So you have 0 voltage here. And when you divide your voltage by your resistance, you have 0 current. So this acts as an open circuit right here, and here, and here. So this is connected. So now what we have is just this current source and this wire connected to A, to B, and it'll go back to ground. Okay? Now, we need to find this current on short circuit. Let's use node voltage again. We have A, we have B, and we have C. C is 9 volts by inspection with respect to ground. Now, if we remember that from what we just did for V open circuit, that we didn't have to use node B's equation. And in this case, you don't have to.